The next step in our hacking methodology is scanning. And with scanning, what we're after is looking to see if we can map out the network and discover what's on it, what applications are running, what ports, protocols, and services, and maybe even figure out what kind of applications and operating systems are out there. Scanning a network basically is the first real active action that we might take as an attacker. Up until this point, most of the things we've done have been either passive or, at worst, non-intrusive. We really haven't contacted the target very much in an intrusive way. Scanning basically is the act of sending network traffic, particularly crafted network traffic, to a host or even an entire network to get responses back from that network or that host. And the responses you would get back can give you details about what's running on the network and how it's set up. The goals of scanning include determining how many live hosts there are on the network and which ones are up and running, what ports, protocols, and services they are running, and, if possible, getting the OS and application versions from the devices. If we have all this information, what we want to do is use it to figure out what vulnerabilities are out there for the hosts and the network. Now, we can scan over basically any network connection, but often, unfortunately, we'll wind up scanning across the internet, so we'll be going through a wide range of devices. So some of the information that you got during the footprinting stage will be helpful. The IP address of the target, the DNS domain name, and so forth. You also could scan via a wireless network if you're within range of that particular target network and they use wireless. Now, targets are the network devices and the hosts. The goal is to get port, protocol, service information, and even banner information so that we can figure out what the possible vulnerabilities are. When we say banner information, some applications and operating systems actually give up a little bit about themselves when you do a scan. In other words, you can scan a particular box, and depending upon the operating system or application that's running on it, it might give up something like an error message or a response that you could use to figure out what's actually running on the box. Now, several different types of scans are available for you to use. It really depends on what your goals are, what you intend to get out of it, and also whether you want to be stealthy or not. Some scans are better suited for when you want to avoid intrusion detection systems or avoid getting caught scanning. So, you may use one or more of these methods when you're scanning a target. You don't have to limit yourself to one method. Now, as far as tools go, there are probably hundreds of tools out there available for scanning. I will tell you that most of them work very similarly, and they offer varying degrees of features. Some of these tools are all-in-one types of tools where they can do footprinting, scanning, vulnerability scanning, and so forth. But some of the basic tools that you'll run into, Nmap and Nessus in particular, are really designed to do one or two things, but they are the best tools out there to do what they do. You'll find some tools that actually use Nmap, which we'll talk about here in a few minutes, to scan a network, and they just provide a really nice front end. One of your goals also should be to avoid detection by intrusion detection systems, as I mentioned earlier. In some cases, you may not care if people know if you're scanning them, but in a lot of cases, you will. You'll want to be able to scan without getting caught. Now, the use of IP spoofing, proxies, and so forth will help you in scanning stealthily and avoiding detection, and we'll talk about those a little bit later as we go as well. So let's look at the goals of scanning. We want to get open ports. We want to get closed ports even, because if the port is closed, that can tell us a little bit of information. In some cases, it can help us determine what the operating system is based upon whether the port is open or closed. We also want protocol information. We want to know if it's running HTTP or FTP, for example. Any network services that are out there, DNS, for example, that would help us to understand what's going on in the network. If we can get any configuration details, that's a plus. Any banners that might help us fingerprint the operating system and applications would be great. If we can get information on what a particular web server is running, such as a particular version of Apache or Internet Information Services, that can help us out as well. Because obviously once we get this information, then we can start researching vulnerabilities to figure out what we can do, what attack vectors we can take. Now, some of the techniques we'll cover over the next several segments include things like full open scans, where they're a little bit noisy and we don't care if we get caught, but also we'll talk about half open and stealth scans, which are usually used to avoid detection. We'll talk about TCP flag scans, ICMP and UDP scans, and we'll cover a little bit about evading IDSs, spoofing your IPs, and the use of proxies. We'll talk about all these things over the next several segments when we discuss scanning. We'll also give you some demonstrations on two of the popular scanning and vulnerability scanning tools, Nmap and Nessus. So we've got a lot to talk about over the next several sessions. The next thing we're going to talk about are the types of scans and different scanning techniques we can use to look on a network and map it out and get ports, services, protocols, banners, and so forth with it. Now, there's several scanning techniques that are available to you that you can use, and really which one you use depends upon a few things. First of all, it depends upon the target you're scanning. Some targets do not respond to different types of scans. For example, Windows is not compliant fully with RFC 793, which covers the TCP IP stack on a host. So certain scans sent to it will not respond. Some of these scans are intended really for Unix type of hosts. The other thing you might decide is the type of response you need from a host. Some scans don't get anything back, while other particular kinds of scans might get something like a reset or an ACK, which would tell you if a port is open or closed or even filtered. So a different type of scan might help you get the response you're looking for. Another thing that might affect whether you're using a particular type of scanning technique or not is whether you're going to be stealthy or noisy. Usually, if you're just going to scan your own network and you don't care if an intrusion detection system picks you up, then you might use something like a TCP full scan, which can be picked up fairly easily by IDSs. But if you're going to be stealthy and you're scanning a network that you don't want anyone to know that you're scanning, then you might use some of the more stealthy techniques. Now, TCP, ICMP, and UDP are really the three things that we use to send different types of traffic to network hosts and get different responses from each one of them. And over the next 2 or 3 sessions, we're going to look at examples of each type of scan and tell you a little bit about each type. Obviously, you need to practice each type, and you can use Nmap to do that or some of the other scanning tools out there. Nmap and just about any other tool that claims to be a scanner can be used to conduct the different types of scans, although definitely I would go with Nmap when possible. The first thing I want to tell you about is TCP scans. Now, TCP is pretty much the most commonly used protocol out there on the internet, probably because most applications use TCP in some form or another. Now, TCP as a protocol can be used to conduct several different types of scans. We have a full scan, a half scan, and so forth. And there are other different scans I'll tell you about in just a moment. Now, because TCP is connection oriented, it has to establish a defined connection with the target host. And the way it does that is through its three-way handshake. Now, I'm not going to repeat basic network theory to you, but essentially you know that the three-way handshake is where one host sends a SYN to another host to synchronize, the other host sends a SYN ACK back to synchronize, and then the first host sends an ACK back, and that establishes the three-way handshake. There are certain scans that can use variations of that three-way handshake to send certain kinds of traffic to a host and get different responses back. So we use the three-way handshake in TCP, obviously, not in UDP or ICMP, and there are 6 flags that we use to control different aspects of communication. There's actually more flags than that. There's 8 flags altogether, but we commonly see 6. Now, these flags basically are bits that are on or off in a TCP segment, and you could turn on all 6 at once or leave none of them on, or turn different combinations of them on and off, and the different flags would be turned on in the segment. Now, TCP also uses ports, and when we're talking about ports, we're not talking about the kind that plug into a switch. We're talking about ports like port 80, which HTTP travels through, or port 25, which SMTP uses, or port 21 for FTP. So we see these different ports used in TCP, and particularly in scanning. And one of the things we're doing in scanning is trying to determine what kind of ports, protocols, and services are open. So a lot of TCP scans will target these particular ports. In fact, they may go through a whole range of ports for a particular host. Now, here's some examples of some types of scans that you can run with TCP, and these are all available to you in Nmap. A full scan, obviously, will send a SYN flag first, get a SYN ACK back, and then send an ACK finally, and that tells us that the host is alive. A SYN scan will send just a SYN flag sent in the segment, you'll get a send ACK back from the host, and that tells you that the host is alive. The big difference here is you can use the type of scan to avoid IDSs because you're not sending the final ACK back, and sometimes an IDS will miss that. A Christmas scan, as it's commonly called, is a type of scan where you're turning on the fin, the urge, and the push flags. And these flags basically get sent to a host for a given port. And if the host responds with a reset, the port is closed. If it doesn't respond with anything, you know that the port is either open or filtered. An ACK scan means that the sending host just sends an ACK. You'll either get no response or reset. If you get no response, the port is filtered, meaning there could be a firewall blocking it. And that's what really an ACK scan is used for, is to determine if there's a firewall or other kind of filtering device in the way between you and the host. If you get a reset, then the port is not filtered. You may not necessarily know whether it's open or closed, but you know that it's not filtered in that case. Now, a send fin is a fragmented scan, and it fragments the TCP segments a little bit. And these flags, the send and the fin, are set with the segment, and you could either get a no response back from the host or a reset. And like the previous example, if you get a no response back, the port is filtered. If you get a reset back, the port is not filtered. There's also other different types of scans that we haven't really talked about, but you should experiment with. The inverse TCP flag, which is listed here. There's also an idle scan, a null scan, and some other interesting types of scans that you can craft with TCP packets. And definitely use Nmap to perform these types of scans. Now, there are other types of scanning techniques other than using TCP. In fact, you can use ICMP and UDP, and even in some cases ARP, to scan a network to see if a host is up. ICMP and UDP scans are somewhat different from TCP scans in several ways. First of all, neither use flags because neither control or establish connections. Now, UDP is kind of the sister protocol to TCP in the transport layer of the OSI model. UDP does use ports, although it doesn't have to, and you'll see common application-level protocols use UDP. Some examples might be DNS, which uses UDP 53, and DHCP, which can use UDP 67. Now, ICMP doesn't use ports at all. Ports don't have any meaning at the network layer, nor with ICMP. In addition to scanning techniques, ICMP can be used to conduct denial of service attacks on different hosts. And that's something we'll talk about a little bit later in the course. Now, as I said, ICMP is a layer 3 protocol. That means the network layer of the OSI model, and it's primarily used for maintenance purposes. We usually see ICMP used when we conduct a ping of a host, when we ping a host at the command prompt to see if it's up or not. There are also other commands that can use ICMP, such as traceroute, and it basically uses ICMP to determine the distance in hops between two hosts. Now, ICMP scanning can be used to determine if the hosts are live and up on the network, but beyond that, they don't really tell you what ports are open or closed. Although, as I mentioned, with UDP, a certain type of ICMP response back can tell you if a port is closed or not. Now, ICMP is primarily used in terms of ping sweeping networks. You could send one to one host, but what you really want to do is scan an entire subnet with it. So that's called a ping sweep. And you would send ICMP echo requests to the host. And if the host is alive, you'll get an ICMP reply back. Now, a lot of network devices block ICMP, so they're basically ineffective in scanning a network. What you might do in that case is use ARP requests to see if a host is alive or not. And in fact, a lot of Nmap scans use ARP by default. Now, UDP, as I said, is a little bit different from TCP in that it does not send the three-way handshake. It doesn't use flags because it doesn't control the connection. And you may use UDP to get responses from hosts that don't respond to TCP scans. Because UDP is connectionless, if you send traffic to a UDP port on that target host, it won't respond when the port's open. It doesn't need to. However, you can use UDP to determine if a port is closed. If the port is closed, you may get certain ICMP responses back. For example, sending a UDP datagram without a port bound to it can cause the host to return an ICMP unreachable packet, and that tells you that the port is closed. Let's go ahead and take a look at Nmap, and I'll show you some of the different scans that can be run using ICMP and UDP. Okay, we're in Nmap, and what I'd like to do is show you just a couple of different scans that can be ran using UDP and ICMP. And basically, if you were to hit your drop-down box here, you could see a ping scan set up here. And a ping scan really uses ARP. If you run a Wireshark capture, you'll see that what's actually happening is ARP requests are going back to see if a particular host is up or not, or a series of hosts. But it's still considered a ping scan. Now the command to do this is -SN and then your target range. And there are other commands you can use to run ICMP scans that use ICMP on the network, and I'll show you those a little bit later when we look at a Wireshark capture. Now you can also run UDP types of scans, and here in this intense scan plus UDP, we see that the -SU is really what causes a UDP scan to run, and there are other options in here. Frequently you'll find that a lot of these types of scans we run, especially UDP scans, are run in combination with other types of switches, because we want to get the most of our money. When we scan, we want to get a lot of different things back. So we'll scan using a stealth type of method, the send scan, and also scan at the same time using UDP. We'll also send different types of packets to determine OS fingerprinting, for example. So a lot of these scans are used in combination with each other, not necessarily by themselves. But a UDP scan is basically -S and a capital U. Later, we're going to look at a Wireshark scan that shows all of these different scans in the capture itself, and I'll show you what the traffic actually looks like as it travels across the network. So that's ICMP and UDP, and again, we'll take a little bit of a look later how those actually look when they're used to scan a host or a network. We're in Backtrack, and we're at the shell prompt. And what I want to do quickly is just show you an example of Nmap at the command line. And I'm going to run a simple ping scan, and we're going to look later at that in a Wireshark capture after we run it. So all we're going to do is just run a really simple one for Nmap. We're going to show you Nmap a little bit more in depth later on in the next few segments or so. So let's go ahead and run Nmap. It's very easy, and it comes built in with Linux, obviously, especially Backtrack. And we're just going to do a simple -SP and the IP address space. And I'm going to say we want to scan 135 through 150. Just a round range there. That's where our hosts are. And so, real quick scan, nothing to it. All it did was send out a ping request, and in this case, actually, it sends out ARP. And all it does is ARP requests for each of these hosts. So it's not giving us back any information on what ports or services are open, just that those hosts are up and alive. That's all it does. Now let's switch over to Wireshark, and I'll show you, this is the same scan I ran earlier, the same type of scan. And what you're seeing here is basically ARP requests that go out to try to hit each and every one of those hosts in that range. And it sends out an ARP request, and in most cases it doesn't get a reply back. But in a couple of cases, here it does, and here it does. That's our CentOS box. And then it comes back with ARP requests out here and here. And we can drill down in here if you like and see the ARP request right here. And then you get the ARP replies right back here. So once it does that, it knows that those hosts are alive and on the network, and it actually uses ARP to do that. There are other types of scans that can use ICMP, but typically those are the kind where we're trying to get different responses from another host. ARP typically will be used just for a simple ping scan. So that's ARP. Now I want to go ahead and show you an example of a UDP scan. So let's go ahead and open that particular capture. And this was a UDP scan we did earlier. And let's go through here a little bit. I'll show you. There's an ARP where we actually scanned first. And with the UDP scan, it's doing several things at once. I actually did, I think, a -SU and a -SS for a send scan. So it will do those as well. And there's the send scan, as you can see. And you're going to get reset and axe back. Now, if we move on through here, we're going to see some UDP traffic. Let's scroll down here a little bit. And the TCP traffic there was part of the send scan there. Scroll down just a little bit here. We'll find it. And there we go right there. That's part of our UDP scan. So what we see here is like a UDP request right here. And as you can see, it's a malformed packet. It's probably a UDP packet that's been changed just somewhat. And then the reply back that we get is a destination unreachable port. And when we get that back, we know that the port is closed. So we know that the port's closed, so it could either be open or filtered. So that gives us a little bit of information about that. So that's a simple UDP scan in conjunction with a SYN scan. Now there's one more I want to show you, and that is a TCP scan. And this was a full open connect that I did, a -ST, very simple scan. And it's going to do some ARP stuff and maybe even some DNS queries. And this kind of looks like some of the same stuff we saw just a second ago. There's some SYNs out there, followed by some reset ACKs. And occasionally you might see a SYN ACK come back. It depends on how it responds. Like right here, here's the SYN, and then the SYN ACK back, or an example of a SYN ACK back, and then an ACK back here. And these are going to two separate hosts. But you can see how in Wireshark you can actually see the responses back that you get. So that's an example of a full TCP connect scan. And again, this would actually show up on an intrusion detection system fairly easily. And as a matter of fact, hosts can have their own host-based IDSs and firewalls that will detect a scan like this fairly easily as well. So that's an example of a full TCP scan there. Again, very noisy, but very reliable. You typically would want to do this type of scan if you're scanning on the inside of your own network, for example, and you don't care about tripping an IDS or something like that. So those are the three different scans we talked about: a ping scan, an ARP scan, and a full TCP scan. The next thing we're going to talk about is probably the most useful tool for scanning a hacker can have, and that's Nmap. We're going to go ahead and talk about Nmap, and then I'll show you how to use the tool and its different switches. And then in the next segment, we'll go ahead and do a demonstration of both the command line version of Nmap and the GUI version. Now, Nmap is probably the most common, most popular network scanner out there, and it's been out there for a number of years. Basically, if you're a hacker or a security person, one of the first things you'll cut your teeth on is Nmap and learn how to use it. Now, obviously, you'd want to use the command line utilities for the exam, but I will tell you that over time, the front end for an Nmap called ZenMap has probably become just as effective, so there's no shame in using the GUI whenever you like. Now, Nmap's capable of conducting a wide variety of scans using all the different protocols we've talked about: TCP, ICMP, and UDP, and different variations. In fact, you have customizable targets and ranges and customizable scans. You can vary the levels of speed and intensity in order to not be detected by an IDS. You can also alter the type of scan in terms of what packets are sent. You might want to do that because you might be targeting a specific OS or a specific type of device, and you only need to send packets specific to that device to get certain things back. Now, as I mentioned, Nmap comes in both the command line and GUI versions, and the GUI is called ZenMap, and you can get that for either Windows or Linux versions, either command or GUI. Now, one thing about Nmap is I mentioned that there are several dozen other tools out there probably that you could use for network scanning. One cool thing is that if you know Nmap, you basically know all these other tools, because most of them will use Nmap as their back-end scanning engine to scan the network. Now, they may give you a different GUI or a different front end and show it in a little bit more prettier fashion, but a lot of them use Nmap. If you can use Nmap, you can use anything else. It may take a little bit to learn how the tool is laid out and the cute little features it may have, but Nmap is really the way you want to learn first. Nmap has a multitude of switches and options. In fact, I'm going to go into Backtrack right now and show you what some of those options and switches are. Okay, we're in Backtrack 5 Release 3, and what I want to do just really quickly is show you a little bit about Nmap and what the switches are. Now, we're going to, in our next session, actually run Nmap from the command line, and I'll also show you the ZenMap, the GUI front end for Nmap as well. Now, to get Nmap to execute, obviously you have to have the package downloaded on your box, and you can do this for Windows or Linux. If you're using Backtrack, Nmap is automatically installed on the box. In fact, in a lot of different Linux distributions, Nmap is already installed. You don't have to do anything. So all we have to really do is type in Nmap, and we'll hit enter, and we get a lot of information. Let's scroll up a little bit and see what we got. Now, Nmap basically gives you several options. It starts with the target specification. You can give Nmap host names, IP addresses, and entire network ranges if you like. In fact, it gives you an example here of how you can put these different targets in terms of names and IP address ranges into Nmap. You can also take an input file name, a list of hosts and networks if you like. It's just a simple text file, one IP address per line or one network per line, and that's all you need. And you can use the IL switch, -i capital L, in the Nmap command to tell it to pull from that list. So if you already have a list of targets, you can pull that in. You can also, out of a range, tell it to choose random targets, because a lot of intrusion detection systems will pick up when you scan sequential IP addresses. So if you use random ones within that IP address range, that might help you get a more stealthy scan. As far as host discovery goes, again, several options here. You can do a ping scan where you don't scan ports, obviously. You can do TCP SYN, ACK scans, UDP, and so forth. So you can really customize the way you scan the box itself. Different scan techniques, TCP SYN full connect scans, simple ACK scans, and so forth. You can also do UDP scans. Everything is in the switches, and you really should know the switches for the exam, the common ones, the -ST, the -SU, and so forth. Some of these are particularly interesting types of switches and options because they can help you go stealthy in a scan. So it would be a good idea to learn how some of these techniques work, and some of them use multiple switches and options to get a particular technique to work. You can also specify port ranges if you're scanning UDP or TCP. You can get versions of a particular operating system and application. You can do OS detection, that's OS fingerprinting, where you grab banners to see what kind of operating system is out there. And you can also guess the operating system based upon the replies back you get from the host. There's firewall and IDS evasion techniques that are out there. Again, it's a very simple program to use, but it has a lot of complex variations and switches that even probably most experts don't use every day. So it's helpful to study some of this stuff, especially prior to the exam, so you can figure out how this works, and definitely practice with Nmap. Use different scanning techniques. Use some of the stealthy scanning techniques in particular. You can also specify the output that you get, what format you get it in if you want to input it into something else. And there's other miscellaneous types of switches. Also, the help gives you different examples that you can use to construct a good Nmap query. So in our next session, we'll actually run an Nmap scan from the command line. In this segment, what I want to do is show you how Nmap works. So the first thing we're going to do is do a scan with the Nmap command line version, and then I'll show you how Nmap, the front end, the GUI works, called Nmap. So let's go ahead and do a simple TCP full connect scan. And a full connect is where the scanner actually tries to establish a full TCP connection with the target. And what happens is it sends a SYN and the SYN ACK, and then the final ACK back. And this is very noisy. In other words, an IDS will pick this up very quickly. If you own the network and you're just the system administrator that's scanning, this is an okay scan to use. If you want to be stealthy, of course, you probably don't want to use this one. But this will demonstrate how to use Nmap in its simplest form. So I've got a couple of hosts out there, and they're in the 192, 168, 163 range. And so I'm just going to scan a piece of that range to see what we get back. So I'm typing in Nmap -ST, and that's for a full TCP connect scan. And I want to do 192.168.163. And I'm going to say .135, for example, through, say, 150. We'll give it that range. I know my hosts are somewhere in that range. And we're going to say OK, and it's going to start off scanning. And it shouldn't take that very long because there are very few hosts up, and a simple TCP scan is not going to come back and tell you a whole lot. It will tell you whether the computer is up and what ports it's running. So it's finished, and if we go on up to the top here, I can show you exactly what it came up with. We know that 141 is up, and it shows us what ports are open: 135, 149, 145, and it also gives us the MAC address. Now, based upon this, we might say that this is probably a Windows box. We also have another box that's up, 142, that it saw, and again, those are Windows ports that are up. We also have a 143 that it really didn't tell us much about, and I'll tell you that that's the backtrack box that we just scanned from. So it scanned itself and didn't find any ports that were open. So we got two Windows boxes. Now, had there been any other boxes up, like another Linux box, it would have probably have detected that as well. So we didn't really do any OS fingerprinting detection or anything like that. It was just a simple connect scan to see if the hosts were up and what they might be running. And we guessed for ourselves that there were two Windows boxes. So let's go ahead and take a look at Nmap FE, which has now become Nmap, and that's the GUI front end for Nmap. So let's minimize this. And I have Wireshark running also that I'm going to start up. And I'll show you the Wireshark capture a little bit later. Let's minimize this for now. And what I want to do is go into Backtrack and find my information gathering tools. And what I'm looking for is network scanners. And right here we find Nmap. Let's open up Nmap. And I'm going to give it the same parameters: 192.168.163.135 through 150. And as you can see, as I put the target range in there, it fills in the command line. This is the actual command line you would use if you wanted to type it in. So Nmap FE or Nmap can do that for you. I also told it to do an intense scan, which is a more involved scan, a more in-depth scan, and it will tell us like OS fingerprinting and a little bit more information. We can do this from the command line also. So I'm going to go ahead and scan, and this is basically just to show you how Nmap works. Let's make it a little bit bigger here. And it's going to scan those hosts, that range, and it may come back and tell us that those hosts are down. And this can actually take a few minutes. An intense scan can take a few minutes, even on a couple of hosts. So when we run this, typically it's a good idea to go get some coffee and come back and wait on it. So I'm going to pause this for a second, and then when it finishes, then we'll have our results here. Okay, our scan is complete. And since this is the graphical version of Nmap, there's some cute little things that the command line version won't do for us. First of all, we can look at our different hosts just by clicking a tab here, and that's kind of cool. We can also click on the services and figure out what it found primarily. It will list all the services there. Here's our output, and again, it's very similar to what we see when we scan with command line, but there's a few other differences here. Basically, we found the same hosts, and it gave us the report of what it scanned and how it scanned, and it told us that it's doing a send stealth scan, because we did a little bit of a different scan on this one. What ports are open, MAC address, and in this case, we told it to do some OS guessing. So it came back and told us that this was Windows XP. So that was a little bit of information. It also did some enumeration. It gave us some NBT stat information and showed us some additional things. And again, this is basically just to show you the GUI anyway. So some interesting information there. It can also tell us things like the ports and the hosts. And one really cool thing is it can give us a little bit of a graphical map. Just kind of show us how the network is built. And obviously, if there's a lot of hosts out there, it looks a little bit better. The different host details and the scans that we did. So that's basically Nmap and Nmap from the command line, two useful tools that you can run to scan a network. And again, these are probably the most common tools out there for scanning. So learn these tools both for the exam and for real life. The next really cool tool we'll talk about is Nessus, which is a popular vulnerability scanner. Now, of course, we're talking about network scanning, not necessarily vulnerability scanning, but you'll find that the two can actually go hand in hand, and that's why I bring up Nessus during this part of the course. We're going to use it a little extensively later on. Now, Nessus is probably one of the most commonly used vulnerability scanners out there. And in fact, if you've been doing security for a number of years, then you probably learned Nmap and Nessus early on. Those are two of the most valuable tools a security person could learn early in the day. Now, previously, Nessus was command line only. As a matter of fact, it was an open source software that primarily you saw on Linux-based systems. Now it's evolved into something much more. Tenable, the company that currently owns Nessus, took it into a multi-platform commercial product. It can run on a wide variety of platforms now, including Windows. There is still a version that you can download free for home use and for limited training use. Now, Nessus has to have its vulnerability databases updated periodically, and it uses updates called plugins. And these plugins contain the most current vulnerabilities that are out there, that have been analyzed and included in the plugins for Nessus. Now, obviously, you'd want to do this a couple of times a week, at least, because plugins are released all the time. These plugins enable Nessus to perform thousands of checks on a wide variety of different operating systems, including Mac OS, Linux, Windows, Unix, and so forth. Now, you can scan entire subnets with Nessus or just one individual host if you like. You can even go in and disable or enable different checks depending upon what different operating systems you know are on the network. For example, if you know there's no AIX hosts out there, then you can go in and disable all the AIX checks because you don't want to waste time checking something that you know is not out there. Now, when it runs the scan, it also displays vulnerabilities that are listed on the host, and it'll display these by the host's IP address and the severity of the vulnerability. And these could be high, medium, and low type of vulnerabilities, red, orange, and green, if you will. It'll also show you informational types of vulnerabilities or just different configuration details about the system that it scans, things that aren't necessarily vulnerable, but you may want to keep your eye on. So what I want to do now is just show you a little bit about Nessus, and in the next segment, we'll go ahead and run a Nessus scan. Okay, let's take a look at Nessus. Now, Nessus runs on the local host on a particular port. By default, it's 8834. Although that can be changed. Now, you'll access Nessus using a web browser, and you'll have to provide credentials to get into the system. And these don't have to be the same credentials that you use to access your computer. So you see different tabs up here, and I want to show you a few of these. Users is where you can add another authorized user to Nessus, and you can give them different permissions. I already have one user in here, that's myself. You also have configuration, and configuration gives you different settings for Nessus and dictates how it will run some of the scans. For example, you have general settings here, you have feed settings, you have mobile settings, results settings, and advanced settings. Let's go a few of these. General settings look at things like the SMTP server web proxy you may have to use, and you may have to put different hosts, ports, from sender email and so forth. And this basically allows you to email the results of Nessus to yourself. You also have feed settings, and the feed requires an activation code, and the feed is basically the Nessus plugins. So you can get an activation code from Tenable for the home feed or for the professional feed. Obviously, that's what you pay for. Mobile settings enable you to sync with an active sync server, an Apple Profile Manager, or Good for Enterprise. The results settings dictate how you can add rules to disable plugins or change their severity. So you can add a new plugin rule here. You can also look at advanced settings. And advanced settings, unless you really know what you're doing, I wouldn't mess with these too much. But you may occasionally have to change them depending upon the environment you're scanning in. The policies is really one thing you need to look at. Now, the policies basically let you alter the pre-built policies that are there, or go ahead and add a new type of scan policy. And with this, you can add credentials to the scan, because sometimes you need to scan Windows and Linux with credentials for the machine, because otherwise you may not get enough information out of them as a non-credentialed user. Now, obviously, if you're doing an internal penetration test, you might have these credentials. But if you're scanning from the outside, or it's a black box type of test, you won't have these. Here, the different plugins are listed, and you can actually enable or disable them, and you can update them as you need to. For example, if you knew there was no AIX boxes on the network, you could disable all these plugins. And there's 11,024 of them, so that would actually save you some time if you didn't run those. The scan templates that are available to you, basically you would use to construct a new scan and use that scan as a template. So you would click that and you would name the Nessus scan. You would determine whether you want to run it now or use a template or schedule it. And then you would go with the different policies that you've created or use the default policies. And we looked at the default policies a few moments ago. So once you would create this, you would run this scan and you can save this as a template to run later. And obviously the scan queue is where you would actually start a new scan. You could base that upon a template you just created or base it upon an existing policy. In our next session, I'm going to show you how to actually run a scan, and we'll scan the network of virtual machines we have on this box. Okay, I'm in Nessus once again, and what I want to do is start a new scan, and I'm going to scan the virtual machines that we have, and there are a few of them out there, and I'm going to scan it from the Windows 8 host. And what I'm going to do first is give it a name, and I'm just going to call it VTC1. And I want it to go ahead and run now. And I'm going to do an external scan because as a hacker, that's probably the first thing I would do. We have to assume that we're not a trusted insider, that we don't have internal access to the network. So we're going to scan this from the outside. And you will get different information sometimes whether you scan from the outside or the inside. So I'm going to put 192.168.163. Let's say 135 again through 150. So that covers all of the possible IP addresses that our VMs are on. So I'm going to go ahead and say run scan, and it's running. Tells me the scan was created, and it's going to run for a little while, and this can actually take some time. In the meantime, if you want to just click the running box here, it will tell you some of the hosts it's finding. And it'll also give you a list of the vulnerabilities it's detecting as well. If we click on vulnerabilities here, so far it's just giving us some information. Now what we could do is click on some of this. We can click on this info here, Microsoft Windows SMB service detection. Basically it's told us that it's found the SMB service, and that's a file print sharing service used in Windows. So it tells us a little bit about it. It tells us the plugin that it used, the risk factor, and which hosts it found it on. So far that's nothing significant, and we can go back at any time and kind of watch the synopsis here. So we're going to let this run for a little while, and when it finishes we'll come back to it and I'll show you what it found. We're back with Nessus, and it's been running for a little while. Let me show you some of the things it comes up with so far. First of all, it's identified 4 hosts, 141, 142, 143, and 138. And if we were to click on some of these hosts, we can see a few things. We know that 141 is probably a Windows box because it tells us a few things about Windows. SMB service detection, for example, SMB registry settings, and so forth. Now, it's come up with 2 medium vulnerabilities on this particular Windows box. And if we click on those, you can see what vulnerabilities it came up with. And these are medium vulnerabilities. And the synopsis, it is possible to log on to the remote Windows host with a null session. Now, a null session can actually be done, some interesting things can be done with a null session when you're hacking a computer, a Windows box. And basically it tells you how to fix it. It also tells you what the plugin results were and the information there. Vulnerability information and the CVE information. And basically it tells you that it was possible to bind to the browser pipe on port 445. So we know this is a Windows box. If we go back, we can look at the other vulnerability, SMB signing disabled. And SMB obviously is a file and print sharing service, and it's not being signed. So it's telling you this is a medium vulnerability, but what you would use this for is to possibly execute a man-in-the-middle attack against the SMB server. So it doesn't think this is a really high vulnerability, and you would see a red vulnerability there if it did. And obviously this is possible over 445 of this particular box. And if we go back to one of the other boxes, we can see that 142 has issues well, and that's another Windows box, but SMB signing is disabled on that, and that's all. Now, obviously we have some other informational things here. OS identification, we can identify the Ethernet card. We can identify that it's a virtual machine and so forth. So a lot of information we can get about the box. Some of it may be of some value, just for information to put in our back pocket, but a lot of it is not going to be information that's helpful at first in hacking this box. We might find a vulnerability later that takes advantage of some of this information we got from the box, particularly the SMB signing. We go back to our hosts again. We have another host here, 143, and all we got was information off of it. And what it gave us is traceroute information. It detected that it's a virtual machine. It told us that there's some ICMP timestamp request disclosure. It's possible to determine the exact timestamp on the remote host. And that could be of some value later. Again, some of this information you can't use directly for an attack, but it may be helpful when you're waging an attack using another exploit. Knowing what the time is on the system box may help, for example, for a particular attack. Let's go back to our host, and there's another one here. And that is the 163.138. And it hasn't really told you anything except that Nessus could figure out what TCP ports are open. And the only port it's discovered so far is port 22, which is secure shell. It's possible this is a Linux box. And in fact, it's a CentOS box, to be honest with you. And the scan is still running, and it will take a little bit of time to run this and to get back all of the vulnerabilities that exist on each box. So we're going to close this out for now, and we'll come back to this scan a little bit later in another session to see what we found. But this is basically just a demonstration of Nessus and how it's used to scan a network and get information from the different hosts. And in some cases, this could just be information. In some cases, it could be actual vulnerability type of information, like those medium vulnerabilities we saw on the Windows box. Now let's talk about how to mitigate the scanning that an attacker can do on us. Now, we actually can't eliminate this, obviously, but we can mitigate and reduce the amount of information that is sent out there that the attacker can use. Now, this actually requires some careful attention on the part of the system administrators and network administrators and even users, and it requires you to configure the network very securely. Basically, what this involves is hardening the TCP/IP stack at the host level, the network device level, and security devices. That means firewalls and IDSs. It also means that you should use intrusion detection systems that are properly configured to catch this traffic as it's being sent by an attacker and to take action. And that could either be to reject or drop the packets or to even block certain kinds of traffic that's out there. Now, blocking these ports and protocols, as well as changing the way different hosts respond to these scans, this will all help you prevent the attacker from getting too much information about your network. Some things that we can do, just in general, to mitigate scans: use network traffic filtering. Obviously, filter things at the router level, the firewall level, and even the IDS level. And what are we going to filter on? Well, we can filter based upon source and destination IP addresses. In other words, we can drop traffic headed to a particular IP on our network, and we can drop traffic that comes from a particular source IP address. Along the same lines, we can also filter by DNS domain. In other words, if we see something coming from a domain called evilhacker.com, just for example, we could drop everything coming from that and not allow it into the network. We can also filter by ports and protocols. We don't have to allow every single port and protocol to come in the network. We can filter those and block all of them except a few of them, only the ones that are necessary to come in. We could also filter by time of day on some devices. Perhaps we will allow certain traffic to come in during certain parts of the day, but not during others. In any case, what we want to do is use a secure configuration for all of our network and security devices. And this also includes any host that faces the internet. This would be like a web server, for example. So you would want to lock down all of these hosts and devices in a secure fashion. So what are the things we need to look at and block and protect? Well, we want to block ICMP and UDP protocols into the network. In other words, if they're coming into our network from another network, we want to block them. We don't necessarily need those to come into our network. We also want to block internal IP addresses from coming into our network. Now, why would you think we might want to do that? Well, it's to avoid spoofing attacks. If our own IP addresses that reside inside our network are coming from the outside. That means someone's trying to spoof our network IP addresses. So we might want to block those from coming through the firewall into the network because they have no business being outside the firewall in the first place. If you have something like VPN traffic or remote access traffic, that actually should be on a different subnet so you can identify it a little bit easier. Another thing we need to look at is changing system and application banners. In other words, making it so that when a box gives up a little bit of information, it doesn't give up too much. You can change banners to say nothing or to say false information when it gives an error message, for example, or when it responds back to a query. Another thing you can do is use both network-based and host-based firewalls. Obviously, the big firewall on the outside of the network is what's going to keep the majority of the traffic out. But keep in mind that some traffic will still come into the network, and it needs to. But you can also use a host-based firewall to prevent the host itself from being compromised, to prevent certain traffic from getting to it if it doesn't need to. You also may want to filter your traffic using border routers. The firewall doesn't have to do all of the heavy lifting. You can filter certain traffic coming into the router before it even gets to the firewall. If you know that you never need port 25 coming inbound, for example, then block it at the border router before it hits the firewall. Or if you know you never need a certain other protocol or port, then block that. One thing that you need to do in your network design is set up a DMZ architecture such that you have an external router and firewall, and then any internet-facing servers that give services to the internet, and then another router and or firewall that blocks traffic coming to the inside of the network. So you have those internet hosts between those two firewalls. This will help prevent anything from getting into the internal network that doesn't need to. Obviously, you would want to close all of your ports that you don't need. If you don't need port 80 on a box, close it. Uninstall any necessary services. This could mean SMTP, SNMP, and so forth. You also want to protect any internet-facing services and servers. Again, put these in the DMZ if you need to. And finally, I would tell you to configure your IDS to block or reject any traffic meeting certain conditions, like if you see network scanning that's coming in at an alarming speed or at a certain frequency or using certain source addresses or using certain types of protocols. You could configure your IDS to block this traffic, and that would help mitigate any scans or other attacks that might come into the network.